How are we doing today? Peachy. Ooh. How nice. Well, it works kinda. Need a delay on my inputs. And my AIs need to be constrained to the proper coordinates. It's all coming together. Oh yeah. Alright. Int random rand range mod tile size. That should do her, I think. Yes. Yes. See how bad this breaks things. 2 minutes to class, everybody. Ding, 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 ding. Too many parentheses in here. Starting to look like Lisp. That's not what I wanted. That's not what I wanted at all. Oh. Did we? It's not mod. It is. Got a function for this. Convert to cells. Idiot. Idiota. Okay, 1 minute. Can do this. All right. As x equals rand range. As y. Do that up here. One minute. Trying to turn this game into an actual cell-based instead of sporadic movement. All right, so my column times tile size. That's what we want. That's the ticket. Renderable. Okay. This is going to be row times tile size. Same for down here. And it's 10 o'clock, we can get going. How neat. These have to be ints, otherwise it's gonna complain. 5 times tile size. How much extra credit will be? Probably just like 5 or 10 points, so not enough that it's really going to be super impactful, but enough that if you need a handful of points, it'll help out a little bit. The first survey, let me rephrase. So the first survey is just for me. So it's for my own personal benefit. That's the one that's worth extra credit. The other one is through the school. I haven't even begun to think about... Can't normalize vector. All right, that's a different bug. Hey, there we go. Cell movement. Woo! He's done it. Dogs we don't care about. Are you in a new room today? Yes. Hi, thanks for noticing. So for my... we don't need to be doing this anymore. Or this. So for my conference, I came... So this is the room that I teach my grad class at night in. This is actually my daughter's school room. It turns out that it's a lot quieter when there's an entire floor between you and the kids who tend to have a meltdown at about this time of day. So we're trying this out now to see if it's a little bit less distracting for all of you. So I'm sure you all love hearing my children scream in the middle of class. Although now my daughter has the downside of having her online classes and having to deal with that. But anyway, so you all got the announcements last night. So if you just joined, it was asked how much extra credit will the surveys be. So the one that I sent out, class sessions, project management, this is just feedback for me to make sure that I am meeting all your expectations, basically that this format is working for you more than it would in other ways. I was going to do this in Google Forms because I wanted to try it out. And then it started doing things like requiring a username and password to get in, or at least like a Gmail account. And since I want this to be anonymous, I wanted to not have anything tied to you. If you want to be anonymous, you can throw your name in there too if you want. It's up to you. But the question was, how much extra credit will these be? Again, if you just joined. So this one, like 5 to 10 points, something like that. Depends on how many people respond. A little bit to bump you if you need. The other one is actually through the school, so that goes to the department chair, Dr. Leidig. So basically, you will tell him how you think I am doing. I guess it's a thing that new faculty to Grand Valley have to go through. I will waffle on making those extra credit. I don't know what the school requirements are for that. We'll see. I like extra credit because I feel like it's a good incentive for all of you to do things that you don't have to do, right? And then you get the side bonus of that's pretty much the only real extra thing I can kind of hand out in class that's not like, here, have some money or something like that. But, all right. So today I am apparently doing that. Okay. I'm wearing my nice dress vest. I had on a suit coat as well, but it looked kind of funny and I was starting to get a little bit warm. That must mean that we are doing project management today, meaning that today you are all going to step back from the role of developer. You are going to become the systems analyst. You're going to become like I said, the project manager, maybe somebody a little bit higher up. And we're going to figure out how the heck we can manage all these projects. Okay. If you are a pure developer, today is going to be mind-numbingly horrible for you. And just as fair warning. If you are somebody who has eyes on maybe becoming a manager someday, this is basically the kind of thing that your future will hold. So you're probably not going to be doing too much development if you go this route. You'll be doing a lot of charts, a lot of planning, a lot of resource management, all of the horrible things that you think of managers having to do. That's what we're talking about today, and the next couple times as well. Slides are back to this slightly squashed format, so this means that it's the blue slide format. But it's got a lot of good information. I'm going to throw a whole lot of terms at you all today. Um, we're going to be covering some of the different strategies. Some only apply to waterfall, some apply to agile. Basically, your process will inform which strategy you use. So here we have a picture of a bird with a massive beak diving into the water. And you might ask, how does this have any relationship to project management? And the answer would be that it has absolutely no bearing on project management whatsoever. I searched for project management in Unsplash photos, and this is one of the results. It was the only thing that didn't look kind of tacky, I suppose. So that's how today's going to be, I suppose. Alrighty, so today we're going to talk about progress on projects, and we're going to talk about personnel. We left off the software design process at use cases, right? So that's where we're getting high-level ideas of what our features are going to be. That is useful for the developer, like we talked about, right? We'll take those use cases and we'll turn them into more detailed diagrams after we get through project management. But we can also take these use cases and start actually planning things out for the project, which is kind of why this is awkwardly interjected, I suppose, breaking up the UML flow. So how do you staff a project is a real question, honestly, right? For you all right now, you got put into your term projects kind of either at random if you joined late or based on how many people were in the group, right? So if I was the one who assigned you to a group, you got placed where I thought you would fit. And me not knowing any of you in person, which is really unfortunate, I can't really assess skills and maybe this person would be better placed over here or something like that, right? I just look at raw numbers. Think of me like that upper level manager who has no idea what's going on in the projects, the low level projects at this point, because I don't have that kind of level of interaction yet. But you all kind of self-organized. The people who knew each other or maybe had common interests, you self-organized into teams. You put your project personnel together based on shared goals, shared knowledge, and if you know each other, maybe a shared idea of what everybody's technical skills are. That's a very organic way of team building. It can also be very dry and number-based, like I need 10 designers and 2 coders who know Angular. I don't know you, the person. I don't know what your background is, how dedicated you are, et cetera, et cetera. I just see you as a number and plop you into this project. That's kind of 2 different ways to put projects together. But what we're going to start off with is how do we identify what needs we have, right? So this is kind of almost a navel gazing, kind of stepping back and seeing, okay, we have people and our teams, right? So we have a large mass of developers and designers and managers and all these people. How can we put them together into a cohesive unit to handle these points on the slides, right? So customers have needs, our clients have needs. Do we understand them? So maybe we have done some use case modeling, we've done some requirements elicitation. Do we understand what they want? And can we have people that can do that, right? So going back to the idea of a team. With that, do we have the skill set? Do we have the resources to actually create the system? So we might understand what the customer wants, but we might not have the resources or technical know-how to do that, right? For instance, if I asked one of your teams, hey, develop me a quantum program, it's possible right now. You can use virtual machines, I think, through IBM, where they have quantum gates that are all in simulation. And you could go out and do that, but you probably don't have the technical know-how or the ability to even access this system. So we don't necessarily have the capability to do it. It's possible, right? It's in the realm of feasibility, but we can't do it yet. So how do we overcome that hurdle? Well, you do research or something like that, right? But not necessarily picking on you. Some of you might be good at quantum computing. I am not. So other things we care about, and this is where the project management kind of comes into play, time and cost. right? Can we deliver this thing on time? You know, whatever time we agreed with the customer on, and how much is it going to cost? Cost is going to be in terms of staffing, in terms of resources that we need, hardware, software licenses, support staff, if you're deploying something and you need to maintain it, right? So all these activities that we've been talking about in the development lifecycle will have a cost associated with it. And it's going to be you, the manager. And when I say you, obviously this is if you are fulfilling this role, right? You have to actually sit down, plug numbers into formulas, into spreadsheets, and see, can we actually do this? All right, everybody, everything makes sense so far? We're going a layer above, basically. So one of the first things we have to consider is creating a schedule. And that's kind of what I was trying to get you all to think about on your term project proposals, where I asked you for a rough timetable, right? So I didn't give you a particular format, right? So don't feel bad if you don't have milestones and dates assigned to them. I just want you to have a rough idea, okay? But our schedule is actually going to take our project and break it into phases, break it into stages, whatever your terminology is going to be, obviously. But this entire software development lifecycle, again, whether it's agile, whether it's prototyping or waterfall or whatever you're using, you can actually break it apart, put it into, you know, whichever visualization software we're going to be using. And phase one, use case elicitation, requirements elicitation, customer agreement, right? So we can actually put these as effectively tasks. We can say we need 5 weeks to talk to the customer and figure out what they want. We need 2 weeks to turn it into use cases, right? So breaking things down into tasks is where we're going to get a lot of kind of positive feedback in a way. And we can actually see what's going to be required. We also can see what kind of interactions there are, right? So think back to requirements. We had high-level business requirements, we had low-level functional requirements, and there will be an interaction between these two activities, right? Let's figure out what our business requirements are, what our customer requirements are, and then once we understand that, we can start breaking it down into technical details. We can take these and turn them into use cases. If we're following a very waterfall-esque model, we have to have our requirements, and then we do our use cases, right? So we would have an activity, and then our next activity would be use cases. One depends on the other. We can also figure out what time that would take, and we can even associate costs if we have an idea of, you know, what our engineers are going to cost us throughout the year. So how do we create the schedule? Generally, what is going to be a good idea is to figure out what our milestones are. And a milestone or a deliverable or a sprint, depending on how you're going to structure things. Basically, you have a thing that has to be done by a certain time, right? So towards the end of the month, probably the last week in October, we'll have our midterms. I will give you a list of deliverables you have to provide for your term projects. That is our milestone, right? This is midterm. I said we're going to have to do some kind of deliverable. This is what we are working towards to show progress. Same thing applies to real projects, right? It might be that you need a set of documents, documents being requirements, customer agreements, class diagrams, test cases, whatever it's going to be. We might have a demo, right? And this demo could be the whole cohesive package. The demo could be simply a prototype. It could be a function working, right? It could be anything that you are going to deliver, that you're going to package up, show that things are working, right? So this is a deliverable, this is a milestone, whatever you want to call it. It's going to be effectively a feature in the schedule that you have to deliver at a certain point. If you don't deliver it on time, then you're overdue, right? So, why is my phone blowing up? My wife's asking if the kids are too loud. I can't hear them at all, so it's perfect. So if we can figure out what needs to go where, that really helps us to inform our schedule. And again, this goes back to having an agreement with your customer. So what are the things we care about? Let's formalize these terms a little bit. So we have activities. This is something that is going to effectively be a line item that has something that has to take place over time, right? So we know what it is and we know how long it will take. That is an activity. We have a milestone. Kind of defined it last slide, but we have completed some activity. What does completing an activity mean? It means I have something to show at the end of the activity. Makes hopefully logical sense that once an activity is done, you would evaluate it. I can't just say, yep, I'm done with my requirements. Okay, well, show me the requirements, right? Have some oversight. We also might have precursors, and I'm not going to talk about these too much. This is basically your dependencies for your activities. So if I am trying to go into the development activity, right? So let's develop the user interface. My precursor might be that I have requirements in place, right? So what has to be done beforehand? We need a duration. So how long will it take? If I need 24 months to develop, a new module for Minecraft, for instance, I would have a set plan that each month I'm going to have to do this, this, and this. So I'd break up that particular activity. But knowing how long something will take will help with planning a lot. We also may have a due date, right? So that would kind of go in line with the duration. If I know that the customer needs a particular revision to a document, so let's say that it's the requirements, right? They want to see what we're developing and they need it by next week. Well, this activity, I know it's going to take 2 months to do. The due date, we're going to put close to, or sorry, the end of the activity, we're going to put close to that due date. Maybe giving ourselves a little bit of flex time in case if something goes wrong, if you have that flexibility in your project. So due date and duration kind of tied together, but they are not the same thing. So just some terms to kind of consider as we go here, right? So this is kind of breaking things down a little bit graphically for you. Effectively, we have our high-level project, right? I'm developing the new artificial intelligence for Tesla, or module for Minecraft, or phone interface, or something like that, right? This is my high-level project. We start breaking things down into phases. And phases is going to depend on your development process, right? If we're doing like the spiral approach, a phase may be requirements, design, implementation, testing, requirements, design, implementation, testing. If we're agile, phases may be, our sprints, or it might be, here's our daily stand-up, here's what we're working on this week, here's our deliverable at the end of the week, right? It just depends on what you're following. So how are you structuring your project? All of these things will effectively factor in some way. They'll probably be called different things, like time tracking in Agile has a different name than it does in Waterfall. You're trying to get the same ideas though. So it's just kind of repackaging in a way. My graduate students absolutely loved looking at the ancient style of software development that is Waterfall, by the way. Nobody does that anymore. But lots of places will do this. So we have our phases. We might break the phases down into steps. And what is a step? Well, it's a decomposed phase, right? What are the major sub-phases of this particular phase? What are the kind of high-level goals here? And then we can break them down into activities, or they're also known as tasks. Nobody. Yeah, pretty much. But this is basically going to be something concrete so that you can show that you finished. The completion of all activities means that a step was completed. The completion of all steps means a phase was completed. All phases means your project is completed, right? So we're just decomposing things to do into basically measurable achievements here. And a couple of the examples in these slides hopefully are interesting to you because this type of process, it applies to any engineering project, right? Project planning is not limited to software. Hardware engineers have to do this. Construction workers have to do this, right? City planning people have to do this. So basically any kind of a project that you have, whether it is software or not, will follow something kind of like this. And one of the interesting things too here, we're going to talk about the critical path method in a few moments. That actually came out of DuPont, I believe, so the chemical company back in the 40s. It was then kind of taken over by construction companies and architects, and then it trickled its way into software engineering. Every project is going to have milestones and steps and phases and all of that fun stuff. So let's say we're going to build a house. We have, let me make sure that I'm doing good for time here. All right, so we have a set of steps when we have to build a house, right? So we may have to do a land survey. We are going to have to get the necessary permits, right? Because if you've ever driven by an empty plot of land saying, you want to buy this plot and build here, well, it's zoned for industrial or it's zoned for residential. Permits issued means that I have to go through a whole set of steps to talk with the county, talk with the city, make sure that I can actually build what I want to here, right? Sounds mind-numbingly horrible if you are somebody who doesn't like paperwork and talking to bureaucrats and all that, but we have a set of things that have to be done to meet this milestone of getting our permits. Right, so here, I'm not necessarily trying to make you into experts on building a house, but start thinking in terms of milestones. Right, so your term projects are having milestones, right? I'm kind of reading your proposals. Well, I already read your proposals, but I'm listening to your chats and all of that fun stuff, and people are talking about, well, we need to implement this level, right? Everybody's going to do a different level. That'd be a milestone, right? Everybody has delivered their level. You have broken your level down into shops, into enemies, into non-player characters, items, what have you, right? These are all milestones that you can say that you accomplished. And then once you accomplish all the tasks, your phase of building your own level, for instance, is done, right? And then when you put everybody's together into a single game, that whole, basically that phase of development would be done. Once you do all of your documentation, your project is done, right? So the end of the semester, our particular focus here is done. So start thinking in terms of milestones, and you can start actually feeling like you accomplished something. That's another thing I should mention here too, which is kind of a good thing if you're doing a project where, let's say it's a term project like we're doing in class, right? You might feel, and not everybody will feel like this, but some people will, like you're spinning your wheels, right? I'm working on stuff. I don't feel like we're getting anywhere. We start seeing things happen, but, I don't feel good about where we're at. Start thinking about the things that you have completed. Start listing out the things that you have to do to complete things. And then you can actually start feeling like you're making progress. You might do something as minimal as add a menu, right? So I've added some text fields, they're clickable. Ho-hum, it's really boring. Nothing, no explosions or particle effects are happening on screen. But getting that menu done means you don't have to do it later. And it's something that is absolutely critical to making your project start, right? So milestones have the benefit of keeping you on track. It also helps you with feeling like you accomplished things. So listing out what you have to do. So here we have some milestones for a house. We can actually start breaking this down into phases and into steps and activities, right? So step one, or phase one, let's do some landscaping. 1.1 is what we have to clear, and we have to grub. So we have to break that down into activities. So let's remove the trees. What happens when you take down a tree? Well, there's a stump left over. You have to get rid of the stumps. After you're done with that, we have a blank plot of land. Well, we need some grass, right? So let's start seeding. Maybe then we have to aerate, we have to seed, we have to water. We have to add shrubberies. We have to add trees back in because we took them out to clear the land. Now we have to put little trees to make it look like it's livable, right? So this whole picture here, this table, is a exercise in decomposition. You have something high level, and then you start breaking it down and breaking it down and breaking it down. And as you go, you can check off, right? Check, check, check. Oh, didn't disperse the seeds. We have to go back and do that. Same thing with building a house. Same thing with building a game or a project of some kind or a phone app, right? These all can be decomposed. This is the kind of thing that I do. Like if I'm doing a little hobby project, I might list out some of the activities and start checking them off. Not only to feel like I'm actually making progress, but so you don't forget anything, right? Make sure that you don't accidentally skip a very important step that you kind of put in the back of your mind for later. All right, good so far? Idea, think like you have to manage a project. Okay, so that's basically all of the key ideas and key terms. Now, how do we actually demonstrate this? Right, it gets back to figures and charts. Basically, how do we show other people where we're at? Assume that we've broken down our project into tasks, into milestones, right? How do we depict this? One way is with an activity graph. Now we're going to have two features here. We'll have a node and we'll have a line. Now a node is going to be your milestones. The line's going to be the relationship between them. So this picture here, very busy, obviously, and not a whole lot of detail, but what do we see? Right, so here's our activity graph for building the house. We have all of our high-level activities that we have to do in order with basically what has to happen before, right? So we're going to start off with our surveying, and we can request our permits in parallel, right? After we have everything in motion for this, we can start excavation, we can get our materials, lay the foundation, etc., 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 right? We have a branching path here where these things can basically be done in parallel if you have enough people. Exterior plumbing and interior plumbing and electrical can all be done at the same time, right? Because you have a shell of a house at this point. You bring in registered electricians, plumbers, so on and so forth, who can all work at the same time. So with this kind of a model, let's go back here. You don't necessarily see what can be done at the same time in this model, right? We just have kind of bullet points in tabular form. But you start graphically depicting things, then you can actually kind of see the flow of activity. Liken this back to your use case diagrams. We started talking about like sequence diagrams and activity diagrams, right? Effectively a similar idea, just at the management level. There is not, so this is kind of, again, at like the project manager, business manager level. So this is not strictly a UML diagram, so you have some flexibility of how you represent things. We can simplify, and by simplify I mean take a lot of the text out. But here we have IDs, right? So 1.1 is surveying. Here we take out surveying to make it a little bit less busy. You just have to reference what activity 1.1 is later. But we can also add some numbers to each of these lines, right? So it's kind of hard to see in this little grouping here, but 2.2 to 2.3, this might take 10 days, right? So these are units of time. This could be days, could be weeks, could be months. It just depends on how you communicate your figure, right? So ideally there would be a legend here with, gray node is a start-stop node, empty node with a number in it is an activity, line designations would be weeks, right? So make sure that you communicate the intent of the model. But again, same concept, just with timing on it. And you can also take this idea of time, add it back into your table, right? So let's say that we want to prepare the site and we have our activities. How many days will each take? This is where you start actually getting a feel for how long each milestone will take to deliver, right? So let's go back to our video game idea. You are each preparing a separate level for your role-playing game. All right, user 1 is creating the shop level, user 2 is creating a cave, user 3 is creating a town. How long will each take? And if you start putting numbers in here, you start actually getting a feel for where your efforts need to be best spent. So for instance, if one of you, and I'm picking on one particular team because I just have it on the top of my mind, don't take this the wrong way or anything like that, but let's say that you're building a town versus somebody building a cave environment, right? If you're doing a town, you need buildings, you need shops, you need people to talk to. Those people are going to need dialogue trees. You're going to need interactions with the shops. Like, can you buy? Can you sell? Can you influence the story in any way by talking to people, right? So there's a lot going on there. Whereas if you're doing a cave, maybe you're throwing enemies in there and you're throwing cave walls and all that. You could make it randomly generated depending on how you're going. Might take less time. than the shop or the town, right? So maybe once you're done with the caves, you reallocate some of your time to help out over here, or vice versa. Maybe the shops are silly easy to implement because it's just one-on-one interactions, but the caves have this very complicated random generation behind it. So if one thing takes 1 day, one thing takes 20 days to do, you can kind of start to see where your efforts need to focus on. And more often than not, too, you can also identify here what's important and what's not important, right? If you're spending 20 days on building a menu system versus focusing on the core of your application, maybe you need to simplify your menu system, right? So this gives you a really good idea of how things are going to track on your project. And as I talk about it, now I'm realizing that I didn't bring my power supply down, so I hope we don't die before the end of class here. Again, planning out your time is very critical for success. It sounds really boring, and me here telling you about it, the developer in me hates this stuff, but the manager who wants to see all of your projects be successful, this is the important stuff here too, right? So take some of this and hopefully apply it to your projects. I'll ask you for some of these diagrams too, so you'll get experience making them. But I'm just trying to get you to think mentally. Let's break things down. All right, so the first one we're going to talk about here is the critical path method. This has been around for a long time, again, since the 40s, at least in formal form. But here you're trying to figure out what is the minimal amount of time to complete a project. And what the critical path is basically the longest duration from start to finish for your project to be successful. So basically, you're trying to figure out what has to be done, how long it will take, and identify maybe not the stretch goals, but kind of the goals that can be done without impacting timing. So criticality is what we're looking for. We have 3 units of measurement here. So we have the actual time, or the real time. So this is where we estimate activity completion time, right? So each activity that we had here before, activities, how long will each take? The available time is how much time do you actually have to do that activity. So these are 2 separate concepts. If I tell you to add a random number generator to generate a cavern system, right, that might take you 10 days to get done. But your deadline's on Monday. So you have, what's today? Today's Friday, right? Saturday. So you have 3 days to get a 10-day project done. So that's the difference between real time and actual time. Has the most propagation delay. Yep. So then slack time, this is going to be what that difference is. This is also, this has another term as well that's like your float time. So the critical path here is that basically this slack time, this float time, basically that each node here is going to be 0, so the time available there. And let me give you a visual to kind of help out with this idea. So this is a very simplified critical path diagram. So this is actually a PERT chart is what it's called. But here we have 3 or 5 activities, so activity 10, 20, 30, 40, and 50. Along the path is how long each will take. So this is your activity diagram from before with a little bit more of a formal syntax, right? So the time between activity 10 to 30 is 3 months, 3 months here, right? Between 30 and 40 is 1 month. Between 40 and 50 is 3 months. And this looks like a whole mess of stuff to all of you right now. But what the critical path that we can get out of this, sorry, these are milestones, not necessarily activities. I should clarify this. We have 2 critical paths here. So the time between B and C is 7 months, right? So 4 plus 3 is 7. The time between A, D, and F is also 7 months. So we have 3, 4, 7, right? So our critical paths is the longest time to completion, basically, for a project. And here we're also showing like dependencies, right? For milestone 10 to be done, or sorry, for 30 to be done, we have to have 10 done. For 20 to have be done, we have to also have milestone 10 be done, right? So what we have here is that E, we can consider subcritical because we end up having a float time or a slack time of 1 month because we're basically 6 months to get here. So we have an extra month to work with basically. A little bit nebulous of a concept in a way, but basically just trying to track out, okay, how many months, how many weeks, how many days do I need to get our milestones completed? And then do we have any leftover slack time to finish our milestones or work on them in parallel? Now, I did the perfectly reasonable thing of quoting Wikipedia here because they have a very nice list of activities for CPM. And if you want more detail, the wiki page is actually very comprehensive. I'm actually fairly surprised. But what do we care about for critical path? We need all the activities. We need the time that each activity will take. We need dependencies, and we need the deliverables. Right, so that is everything that we see here. What activities have to happen, what milestones, how long will each take, right? So these are kind of the key concepts for CPM. Makes sense more or less. Some of the things to consider here too, while I wait for any questions to pop in, this is but one way to model out project planning, right? There are a plethora of techniques. This PERT model here is a slight variant of CPM, or it's one of the models used in CPM. There are other ways to show that as well, right? So we're going to move on to the more contentious one. And when I say contentious, I showed a variant of this figure to my grad students who are in the systems analysis class, and they laughed when I showed them this because nobody uses this anymore. This is ancient stuff. This is a Gantt chart, and why this is contentious is it is fraught with ways to abuse the system, I suppose. So this is a wonderful way to model your project if you're doing waterfall. If you are going agile, this is pretty much useless. Just we'll put that out there. But it's good to be aware of how these things work if you go to a project where they use them, right? So what we have in this very busy figure, and if any of you have Microsoft Project, this is basically the chart you're getting out of it. I will say when I was a grad student, I started doing a Gantt chart for all my timing, and after about a week, I just gave up on it because I started back planning and changing days to make it look like I was completing things. So, again, stuff you don't do anymore, but kind of helpful if you have an idea of what all your activities are at the outset, right, and how long they will take. Right, so here we have basically bar charts of how long a particular activity is going to take. Right, so we have the start, we have the finish, we might have some slippage where we have some kind of extra time built in. But let's review a spec. It's going to take us 2 months. Right, let's review our budget. Again, middle of February to the middle of April. And you just kind of have this propagating chart of where activities will be completed. Right, and if you've never seen this before, this might actually be a good idea, right? Because you can actually plan out your time very nicely. If you have experience with this, you probably will know that these figures, well, let's say that we skipped our deadline for review specification. At our next review, I'm just going to kind of bump this up down to here to make it look like we're still on time. It's kind of why I said it. These are kind of iffy on their usage. If you follow them correctly and you know all of your activities and you know everything up front, again, waterfall, right? This will work. If you get into, well, we have to go back and fix our spec because we're doing it in parallel to our prototypes, this goes out the window. So kind of a useful thing. Now let me maybe show you in parallel here. Yes, exit. Okay. So I don't have project installed on my computer, and I'm going to guess most of you don't either. If you want to do some of these charts, it's not in the draw.io, but I've signed up for Lucid Charts, so lucid.app. You can sign up for free with a Gmail account. So I just use my school one. But you can actually build these things out in this kind of format. And if you pay for it, you get a lot more features, right? This is just high-level tasks. You can add milestones and things like that. But again, this gives me a feel for when things have to be done and what the task is. Lucid.io has some funny memes. Does it? I'll have to check those out. Lucid.io. Is this something that I want to pull up in chat here? I'll save that for later. If you have any good ones, feel free to throw them my way. But let's talk about my my little game here that I was dinking around with before class. Right, so right now I just added in tile-based movement or cell-based movement, right? So my duckies are moving around on a cell basis. My guys moving around on a cell basis, the dogs are not, because they're still going on a vector-based movement. I don't think any of you saw this, because I did this while I was at my conference the other day. So dogs follow me, ducks kind of randomly move around. And my next step is data camera system to scroll a little bit nicer. But let's figure out camera movement, right? So that's going to take me 2 days, hopefully. Let's add cell movement to dogs. That might take me 1 day. So again, I can start to see dependencies here, right? Camera movement doesn't necessarily depend on the dogs, or I could do these in parallel if I'm feeling frisky, right? But these have to be done before I start world building, for instance. Right, so just kind of randomly picking things here. Again, can be useful if used correctly, but much maligned in the current current notion of what project planning is. All right, so we have 8 minutes left, and I'll have to check out your YouTube video there after class. But with our Gantt charts, we can start figuring out who we need for the project at what time. Right, so if we have this notion here, all right, here's everything that has to happen between January and May. Well, this is all system planning. So maybe between January and May, I'm going to need more system analysts on board and less developers, right? So this particular figure is showing whether you're underloaded or overloaded with work, for instance, right? So when do we need the most people on the project? I'm not going to bring the developer in until I actually need them, right? So think of yourself as say you're a mid-level manager, right? And this is a slightly different figure as well. But I'm planning out my project. I used a Gantt chart or similar. I see that January through May, we're doing all requirements, customer, client-based stuff. We're scoping our project. We're doing all the outset stuff, right? Well, let's say this is months, not days. So month 1, 2, 3, and 4. I only need developers later on. So the people who are developing for this project can be moved to another project, right? Where they need active development. Whereas when we get later on in the project, I'm going to need less designers, I can reallocate them. So you're not just going to go out and hire people to like subcontract for you for X months. You're going to move your pieces around to where they're needed most. And if you start planning things out ahead of time, you can actually do this kind of activity a little bit more intelligently than randomly moving people all over the place, right? That's where you get into a lot of morale problems, frustration problems, things of that nature. So this figure here is a very common type of histogram. If you've never read one of these before, basically it's a bar chart, except you have multiple bars overlaid on top of each other. So for instance here, day 3, I see that I need 4 people. One of those people will be a developer. 3 of them will be designers. Here, day 5, I'm going to need, let's see, this is a little bit harder to read, I suppose. So I need 2 designers, I need 4 developers, and I need 2 testers, right? So you can also break it down into tabular format to make it a little bit clearer if you need to. But we can start, again, planning things out. So we have our timetables, we have our resource tables. We can also figure out expenditures, which If you've never done budgets, it sounds pretty horrible. Um, but you can actually figure out what your cost plan will be, right? So that was one of the things we talked about at the very, very beginning when I outlined this. You have to talk about cost. So you look at a chart like this, and here we have the months of the year on the bottom compared to how many dollars you have to spend. And expenditures are basically like paying salary, paying benefits, paying for tools and technologies and things like that, right? We plan how much money we expect to spend, and then you compare that to what you actually spend. And hopefully you're not too far off, right? If you have a figure like this, again, it looks very generic, but if my actual expenditures are way up here, well, what does that mean? It means you're way out of budget. It means that your project cost more than you anticipated, meaning that you're out a lot of money and people are going to be upset at you. Whereas if you underplan, maybe you oversold things, maybe you ended up like understaffing or. But basically, when you start adding money into the equation, you have to start forecasting and things like that. So what I think we're probably going to end with today is let's talk about the other side of things. Because, well, actually, the book that this set of slides is based on doesn't talk about Agile really in terms of how it's done. Let's stick with Gantt charts, right? We love Gantt charts. It's also an older book. If you're going Agile, you may have the notion of a burn down or a burn up chart. So this is a little bit of a different view. It kind of looks like this last figure here, right? Well, what we're looking for here is basically your project velocity. And all that really means is what is your gradient of descent or your gradient of ascent. If you've never taken a math class before, basically we're just figuring out like slopes and things like that aligns. So what's the difference between these two? Because these are both effectively showing similar things. Depending on your team, you might use one over the other, or you might use both. It just depends. But a burn up chart, so this one over here, is going to show you how much work you have completed to date versus what the scope of your project is. A burn down chart is basically showing you how much is remaining to be done. So let's say here, and this is kind of a amorphous axis of things to do, right? So there's not an actual value here. I've got 10 things left to do, basically. I have, over time, I'm reducing the amount of work left to do, right? Whereas here's the scope of our project with all things we have to do, and here's how much we've completed towards that goal. So just by looking at how steep your lines are shows you how much effort has been expended. It's kind of a simplified view of looking at effort, right? So what does this tell us? Well, let's pretend that we're hiding this one here, right? So let me just pretend like you don't see the burn up chart, right? I'm putting my hand over it on the screen. You can't see it. If you only look at the burn down chart, what do we see? Well, you all see a blue line and you might not know what it means. You're waiting for the professor to contextualize it. We see between January and February, this line is flat. Same between April and looks like June, right? So here we have flat lines. Same here. What is a flat line in terms of a burn down chart? It means that we did not complete any work, right? Because this is the amount of things left to be done. Let's pick on this time, it remained constant. If you only look at this, looks like your engineers sat there twiddling their thumbs doing nothing. Okay, well that's not really good, right? Why did we have this hiccup here? Burn down chart doesn't tell you this. But if you look at the burn up chart, are completed, and this is actually the same figure, by the way, I should mention this. So this is the exact same activity, just two different viewpoints. If you look at the burn up chart, this is the amount of work completed. Again, so this is effectively like the inverse of this in a way. We actually see a fairly steady increase, right? A little bit of a hiccup here, but we're always going up. So our engineers are actually doing their job. Well, where's the difference? That's where this extra line comes into play, the scope of things. So between February and April here, Our scope stayed the same, so we made a hell of a lot of progress on our project because we didn't have to deal with new things. However, between April and June, our scope increased significantly. What does that mean? Well, if you look at this, our engineers had to deal with a lot more effort. However, they were incrementally completing things. Does this make sense, the difference here? Because this is actually kind of an interesting viewpoint where, depending on which model you present, you can either show things that are really, really good in terms of this burn up chart, or your team kind of looks bad. What happened here? And keep in mind, I'm going to leave you with this idea here too, since we're out of time. If you show this to a manager, they're going to get really pissed off. What the hell are you doing between these 2 months? But you show them something like this, then you can actually make the argument, well, you increased our scope. So that is where I will leave you. I hope you all have a wonderful weekend, and we'll continue on with more management on Monday. Hopefully it stays nice so that we can at least enjoy a little bit of summer. So I'm going to check out some memes. We got office hours starting here soon. And yeah, bye everybody.